In this video, we're going to look at how to determine how many significant figures a given number has. And I'm going to do this in two different ways. The first method is going to be the way that I think about significant figures. And then the second method, which will be on the next slide, is a way that some of my students have showed me the way they like to think about it. And both of them will give you the same answer, and you can use whichever method you prefer. So, in the first method, all non-zero numbers are always significant. The only questionable numbers that we don't know whether they're significant or not are zeros. And so there are just a couple different rules for determining whether or not a zero is significant or not significant. So first of all, what I call sandwiched zeros are always significant, right? And by sandwiched, I mean the zeros are between two non-zero numbers, right? So these zeros are between a 5 and a 2, or this one is between the 2 and the 2, right? So they're sandwiched by non-zero numbers, so they're always significant. Leading zeros, or zeros that come before any non-zero numbers, are never significant. And so this is typically going to be the case where we have numbers that are less than 1, right? So I've got these zeros in front that come before any non-zero numbers, so these zeros would not be significant. This is a sandwich zero again, so that guy would be significant. So this number would have 4 significant figures. Trailing zeros can be significant or not. If there is no decimal place written explicitly with the number, then the trailing zeros are not significant. So in this number, there's no decimal place, so the zeros at the end are not significant. So this number would have 3 significant figures. Again, there's no explicit decimal place written, so the trailing zeros are not significant. These would be sandwich zeros, so they are significant. So this number would have 1, 2, 3, 4, 5, 6 significant figures. If there is a decimal place written explicitly, a decimal point written explicitly, then the trailing zeros are significant. So in this number, there is a decimal point written explicitly, so the trailing zeros are significant. So this number would have 1, 2, 3, 4, 5 significant figures. Again, in this number, there is a decimal place written explicitly, and so the trailing zeros are significant, right? These would be leading zeros, so they are not significant. So the 1 and the 5, non-zero numbers are always significant. The trailing zeros in this case are, so this number would have 5 significant figures. All right, so another way to determine significant figures is to just ask one question. Is there a decimal point written explicitly? If there is, then we start counting from the left. Once you get to the first non-zero number, that digit and all other digits after it are significant. If there is not a decimal place, then you would start counting from the right. Once you get to the first non-zero number, all digits are significant. So let's look at a couple examples, and I'll do them both ways. So my way, I take a look at this number. The 2 and the 4 and the 6 are significant. The only question is the zeros. These are trailing zeros because there is no decimal point written explicitly. Trailing zeros are not significant, so this number would have 3 significant figures. If I use the second method, is there a decimal point? No, so I start counting from the right. And so nothing is significant until I get to a non-zero number. So not, that 6, now everything after it is significant. So the 6, the 4, and the 2 are all significant. So again, I come up with 3 significant figures. Method 1, when I look at this number, I see I have leading zeros. They are never significant. The trailing zeros are significant because I have a decimal place. So this number has 1, 2, 3, 4, 5 significant figures. If I use the second method, I ask, is there a decimal point? The answer is yes. So I start counting from the left, and nothing is significant until I get to a non-zero number. So not. The 4 turns it on, so the 4 and everything after it is significant. So this number has 1, 2, 3, 4, 5 significant figures. Same result we came up with before. All right, again, method 1, when I look at this number, these are trailing zeros, but there is a decimal place, so they are significant. So this number has 1, 2, 3, 4, 5, 6 significant figures. Method 2, yes, there's a decimal place, so I start counting from the left. The first number is a 9, it's not 0, so the 9 and everything after it are significant. So this number has 1, 2, 3, 4, 5, 6 significant figures. Same thing for this number. I have a decimal place, so trailing zeros are significant, so this number has 4 significant figures. Or, second method, I look, there is a decimal point, so I start from the left, the 3 is significant, 1, 2, 3, 4 significant figures. All right, and then the last example, I see that this is a sandwiched zero, so by method 1, I know that that zero is significant. These are trailing zeros. They did not write the decimal point explicitly, so the trailing zeros are not significant, so this number has 3 significant figures. Or, second method, is there a decimal point? No, so I start counting from the right, so not significant, not significant. The 8 is, so the 8 and everything after is significant, so this has 1, 2, 3 significant figures.